We are doing number 4 in the friction packet. The goal of this problem is to determine the minimum value of mu sub s that would prevent the system from accelerating. First, let's make the positive directions right and down. Moving on to the free body diagrams. For mass sub 1, we know that there is weight on the block by earth, normal force on the block by surface, and tension pulling to the right, and friction pulling to the left. For mass sub 2, there is tension pulling up on the weight on the block by the earth. So the problem is asking us to determine the minimum value of mu sub s, or find the minimum static force, frictional force.
Let's start with mass sub 1. The sum of all forces is equal to mass sub 1 times acceleration. In this case, the sum of forces equals tension minus friction in the left, and therefore tension minus friction equals mass sub 1 times acceleration. Because we know that acceleration is 0 and we want to prevent the system from accelerating, we can put acceleration equals 0. And since there is fraction, let's substitute. So now we have tension minus mu sub s times Newton, in which newtons equals mu sub s times mass sub 1 times gravity equals 0. Let's move on to mass sub 2. So the sum of all forces is equal to mass sub 2 times acceleration. Because this mass is moving with a vertical component, the sum of all forces equal the weight, which is mass sub 2 times gravity, minus the tension in the up direction. Again, there is no acceleration, so let's solve for t, in which t equals mass sub 2 times gravity. Now we can plug in the tension we got from using mass sub 2 into the mass sub 1 equation. We get mass sub 2 times gravity minus mu sub s times mass sub 1 times gravity, which all equals 0. Our goal is to isolate and solve for mu sub s. Yeah, so when the gravities cancel, we are left with mass sub 2 over mass sub 1 equals mu sub s.